one attribute that we like our voting systems to have that the majority of plurality methods didn't is we like for there to be a way for voters to say not just that I like this candidate, but that I like this candidate more than all the others, and I like this other candidate second most, and I like this third candidate the least, and so on. In other words, we like them to be able to show how much they care about each candidate. To do that, we're going to need something called a ranked voting system. Right? In a ranked voting system, voters don't just cast a vote for a single person. They take all of the candidates and list them in order, who they prefer the most, who they prefer second, third, fourth, and so on, all the way down to the bottom, however many candidates there are. So we're going to look at a specific example of that here. So I've got an example voting outcome here. We have 4 voters voting for 3 candidates. And each voter has taken those 3 candidates and ranked them. Their first preference, their second preference, and their third or their last preference. And over on the right-hand side, I've got the points that we're going to assign to each position. All right, so every first place vote is going to get 3 points. Every second place vote will get 2 points. Every third place vote is just going to get 1. Okay, so let's work through this for each candidate. Let's look at candidate A. Candidate A got 2 first place votes, 1 second place, and 1 third place. So how does that turn into points? Well, it's 2 times 3 for the 2 first place votes, 1 times 2 for the 1 second place, and 1 times 3 for the 1 third place. If you do the arithmetic, add those up, candidate A ends up with 9 points. Candidate B, on the other hand, 1 first place, 2 seconds, and 1 third. Right, so if you, again, we're going to do the exact same arithmetic here, exact same procedure. That's 1 times 3 for the first place, 2 times 2 for the 2 seconds, and 1 times 1 for the third. That's going to give us a total of 8. And finally, if you can pause if you like, or if you want to work through candidate C on your own, see if you can come up with that result and compare it to mine. Candidate C was kind of the reverse of candidate A, right? 1 first, 1 second, and 2 thirds for a total of 7 points. Okay, so who wins? Well, candidate A. Candidate A ended up with the most points, so they are the winner of the election. Okay, so let's take a look at this and drill down a little bit and kind of see what's going on. Candidate A won because not only did they get a bunch of first place votes, they were liked the most by a lot of people, half the voters, but they didn't do too poorly in the other categories. There was only one person, voter 2, who really kind of actively disliked them, and that ended up with a reasonably high score. Candidate C, on the other hand, had the reverse situation. Candidate C was actively disliked, if you will, by voters 1 and 4, and that was a real drag on their total. Candidate B is kind of the middle of the road candidate. Not really disliked by arguably three of the 4 voters, but not really anybody's favorite either. Right? So that wasn't enough to push them up into the top category. Okay, so the way I've laid this out here, this works for a system like this where there's a relatively small number of voters, and we can lay out each of their individual voting tallies, if you will, and do the arithmetic on them. When we start talking about larger elections, you really, I mean, if you got even with just 50 voters, you really don't want to have a 50-column wide voter table here. So what we're going to do is we're going to do a summary table, right? It looks like this. Instead of having individual voters above each column, I have the number of ballots that had that particular arrangement. And so, for example, looking at the first column here, 12 voters put A first, B second, and C third. 15 voters did the opposite. They put C first, B second, and A third, and so on across the table. For a total, what do we end up with here? 12 and 15 is 27. There's 44 voters altogether. Okay, But the actual process, the actual calculation is going to be the same. Right? So for example, looking at candidate A had 19 first place votes. That's this group and this group. They had 10 second place votes coming from this block. And finally, they had 15 third place votes coming from this group. Okay, so what does that come out to? Well, the calculation is exactly the same as what we did on the last slide. 19 times 3 for the first places, 10 times 2 for the seconds, 15 times 1 for the thirds, and that comes out to a total of 92. Now, again, if you like, you can pause, right? If you like to work through the other two candidates on your own, then you can come back and see where I ended up. So candidate B is interesting. This does not bode well for this person, but they had 0 first place votes. There's no voters who really preferred them over everyone else. 27 second place, 17 third. You do the math here. That comes out to 68. And finally, candidate C. I'm feeling good about candidate C just because they have so many first places, right? 25 first place, 7 second, and 12 third, which comes out to 101. So yeah, that puts candidate C as the winner of this particular election. Okay, so this is good, right? This Borda method avoids that issue that we had with plurality and majority voting. It lets voters kind of express their opinions at a final level of detail. Right? It really lets you drill down into who they really care about versus who they really would prefer not win. Right? But there are some flaws with this method. We've got 2 more methods that we're going to talk about. So I'm going to reserve looking at the flaws with the remaining systems until we get to the lecture after that last one. Then we'll kind of look at all of the potential issues that could come up with voting methods all at once, and we'll look at some examples of how they apply to each of these here. So in the meantime, in the next lecture, we're going to move on to our next system, which actually combines 2 of the ones we talked about so far. Right? It's going to combine this Borda method with the plurality method in a system that's called plurality with elimination.